Good morning, everyone. My name is Carmen Palacios Berraquero. I'm the founder and CEO of New Quantum, and it's my pleasure to welcome you to the Inaugural Forum of the Quantum Datacenter Alliance. But first, let me welcome you to this venue today. We're at the Battersea Power Station Control Room A in the south bank of the Thames River. And many of you will recognize this building from the cover of Pink Floyd's Animals album. Yeah, so we're all super excited about that. But beyond that, this building has a really interesting history and architecture that make it a really symbolic place for us to host our first event. So until the 1930s or so, power in London was generated by very small companies with small power stations that would deliver power to local industries and shops and houses. And then in 1925, Parliament said the national grid should be a single unified system with a set of standards around voltage and frequency, which wasn't there before. Each company was using whatever they wanted. So all of these little companies joined up to form the London Power Company. And they proposed to create a smaller number of larger power stations. And the Battersea Power Station was the first proposal of that wave of power stations. So Power Station A, where we're sitting today, was built in the 30s, and then there was a stop gap for World War II. And Power Station B was built in the 50s, and they were in operation until the 70s or 80s when they were started to get decommissioned. So together, they're one of the largest brick buildings in the world. And at least for Power Station A, which was built before the war when there was more money, it was given all these beautiful Art Deco fittings like the parquet wooden floors, there's Italian marble in the turbine hull, and all these details. So in fact, Battersea Power Station is two power stations working together, A and B. So there's a nice history here of modularity to scale and distributed control. You know, the control rooms were working together to distribute power to the grid. And at its peak, Battersea Power Station supplied a fifth of London's power. So from this power station to the first sort of vacuum tube computers, our first data centers to today's data centers and computer clusters. We've really, over the past century or so, we've come together to create these large-scale engineering projects that are infrastructure to process, control, and distribute resource, whether it's power or information. And I think by now we've learned a few common lessons that help in these large-scale projects. So modularity maybe is one of them. Building redundancy to ensure uptime and continuity maybe is another one. And some sort of agreement or, perhaps towards standards between people across interfaces. And all of these, including the power station, are sort of symbols of its era. And I think everyone here has the really unique opportunity and privilege to think about how the symbol of the next era is going to look like. So a future where what we're distributing is another kind of resource, entanglement or quantum information. And this is really why we founded the Quantum Datacenter Alliance, to learn from decades of experience and to form an industry that can come together and accelerate the path towards our ultimate goal, which is to create robust and large-scale quantum computers that can do good for the world. So New Quantum gathered a group of 6 founding companies to the Quantum Datacenter Alliance: Cisco, NTT Data, OQC, QFox, Quantinuum, and QERA. And we hope that we'll welcome many more over the next years. And the reason why at New Quantum we care about building the ecosystem for quantum data centers is because we're a quantum computer networking company. We spun out of the University of Cambridge in 2018. We're a team of over 60 people now between Cambridge and California, and many of them are here today. They've organized this event. They'll be helping out throughout the day and speaking at various points. So thank you to my team, because they have been incredible at organizing this fantastic event. And really what we're building is the networking hardware that will allow us to create entanglement links between different QPUs, and together with the QPUs, create what we call an entanglement fabric that can be error corrected. So what we're really trying to deliver is fault-tolerant scale-out. Last week, we announced our quantum networking unit, which is the sort of first industrialized embodiment of two key parts of the network: the dynamic entangler, which is the photonic layer that coherently routes photons and distributes entanglement, and the real-time network orchestrator. And it's funny because our figures of merit for our quantum networking unit are about synchronization and switching speeds. And Simone pointed out to me earlier that here in this control room, there's a synchroscope that was used to synchronize the 66 kilovolt output to the grid. And it's full of switchgear, of course, to control the power to different parts of London and different parts of the station itself. So the QDA today is all about how are we going to build these large-scale machines, right? So most people here will be from a quantum company or a data center infrastructure company. We're talking about what are the right architectural blocks. So the QPUs, the network, the error correction, the data center integration. Maybe there's more. We'll talk about what are the interfaces between these blocks, what are the common language and words that we can use to refer to them, what are the infrastructure needs. But we hope that the QDA tomorrow will change, and it will be more around how we use these machines. How first we create an interoperable and high quality business service, and how we include end users and customers in this alliance. So we aim for this, for the Quantum Datacenter Alliance, to become a place that can help with commercial pool and help create commercial opportunities for all of our technologies. So in the spirit of learning from the past and from other industries and building it, we've prepared an agenda that I think is going to be really fun. So we'll start by the scene setting and big picture session. So we will learn from Hermann Hauser about the history of classical compute and lessons from there. From Archana Sharma about lessons in creating a super big scientific project like CERN. And then we'll hear from Anna Haid from McKinsey around where we're today with the quantum computing market, and she'll give us a sneak preview of McKinsey's 2025 Quantum Technology Monitor, which is about to be published. And importantly, what are the use cases that have come, that we've identified that are good for the planet. We'll take a break, and then after we'll start with the build it. So we'll go into the stack. We'll start by asking QPU companies and interconnect companies, how would you manufacture or interconnect a data center's worth of QPUs or network? And we've really asked people to prepare answers to these perhaps unusual questions. So we're really trying to get to it straight away. We'll hear from different quantum error correction players on the different approaches there are today to do distributed quantum error correction, so surface code, quantum LDPC code, and hyperbolic flow K code. And then we'll end with data center integration. So we'll have a panel including NTT Data, Cisco, and the NQCC around how do we integrate these machines into our current infrastructure. And we'll end with a talk by PsiQuantum on their vision for a quantum data center. At the end, we'll also talk about QDA governance, what's going to happen in the next year or so, how are we going to grow and accept new members, and what are the plans for what we're going to be discussing over the next year. So just want to thank everyone. We've got over 100 delegates today from 13 or so countries. So welcome. I hope you enjoy the day. And I wanted to point out also that UNESCO has officially listed the QDA event as one of the events of the International Year of Quantum. So well done to all the team behind this. Okay, and with that, I will introduce our next speaker, who almost doesn't need any introduction. Herman Hauser, co-founder of ARM and of Amadeus Capital Partners, who will talk to us about learnings from the classical computing industry. Thanks, Herman.